what did we offer in RabbitMQ for streaming, and kind of what's the general landscape of that?
Yeah, so as you said, traditionally RabbitMQ, and MQ stands for message queue, has been about queuing, and streaming capabilities were introduced in RabbitMQ 3.9 4 years ago. So by now, this is a very major feature in RabbitMQ. And streams are different from queues. So streams are an append-only log, and they provide non-destructive consumer semantics. So this means that if consumers receive messages from a stream, those messages are still in the stream because it's an immutable log, right? So in contrast with queues, if you consume messages from queues, those messages are being removed from the queue. And there are a lot of interesting use cases why you would want to adopt streams. So one use case would be, for example, large fan outs, because your publisher sends a message into a stream, and then that same message can be read by many different consumers. So in contrast, if you use queues, you would need to bind one queue per consumer to an exchange, and then every queue gets a copy of that message, which also works, but it's more scalable to do it with streams.
Right.
There are also other features. For example, you can do a replay and time traveling. So you can have your consumers attach anywhere in the stream by offset or by timestamp. And then they can consume messages, but they can also go back again and consume the same messages again, or skip a certain time range. Streams are also there for high throughput. So we've designed our own RabbitMQ specific streams protocol, which enables you to publish and consume millions of messages per second.
Millions per second?
Exactly. And streams also provide large backlogs. So the amount of messages that you can store depend on your disk capacity, right? Because the messages are stored on the disk. And this is also a bit different from queues, because queues, they converge towards the empty state. So you want to have your queues empty as much as possible. Whereas for streams, they converge towards the full state. So the stream becomes full, and then all segment files in that stream are being deleted over time, depending on how you configure your retention policies. So you can, for example, say you want the stream to be available for 1 week. Then all data older than 1 week are being automatically deleted. There are a few more use cases for streams. For example, they provide strict message order because, again, the stream is immutable. And this is different with queues, right? If you have multiple consumers from the queue, then one consumer can requeue the message, it can discard messages. A consumer can have network connectivity issues, so it disconnects and the messages are automatically requeued that were previously checked out by that consumer. So messages might get out of order if you don't pay attention. And there are ways to have strict message order also with queues. For example, if you use the single active consumer feature, but then you only have a single active consumer. So with streams, you have strict message order by definition, but you can have multiple consumers. And then one last aspect I would like to mention about streams is the protocol interoperability. It's very nice in RabbitMQ. So you can use any protocol to publish to a stream, for example, AMQP or the RabbitMQ streams protocol, but also MQTT, so you can have IoT devices which publish into a stream. So interoperability is one of the strengths of RabbitMQ.
It's a bit mind-blowing how much capability there is there. Now, from a performance point of view, you said it's millions per second, so I'm presuming that means that's faster than if you were to use message queues, right?
Yes, exactly. And that's because streams under the hood, they transfer entire chunks. So we'll talk about what a chunk is later on in more detail. And they use, for example, the send file system call. So the broker will dispatch entire chunks without reading any data into user space, into memory. So this is very efficient. And with the other message queuing protocols, for AMQP or MQTT, they are message oriented. So they are based on a per message level. So the broker needs to pass each individual message and then sends it to the client. So that's why streams are much more performant.
Under what condition would you really want to use queuing instead of streams?
Exactly. So it really depends on the use case. So queuing is useful if you have, for example, certain jobs that need to be processed or one-time events that need to be processed. In this case, you don't need to hold on forever in the broker for that particular message. You just want to make sure that your publisher sends some information and then some consuming application are processing it. So as soon as one consumer processes that message, it gets acknowledged and then immediately deleted in RabbitMQ.